Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present about the assignment 5 and task 2 for introduction to mathematical economics. Hi, my name is Putra in Zickery by Ahmad Fairul and my matrix number is 288412 and I'm now unofficially 20 years old and I'm currently living in Johor Bahru, Johor. Let's move on to business. Question 1, A. Determine whether the function f(x) is equals to x to the power of 3 minus 6x squared plus 18x minus 15 is concave upward and where it is concave downward. So the first step is we need to find the first derivative of x. As we can see, x power of 3 given the function x is x power of 3 minus 6x squared plus 18x minus 15. So if we do the derivative, we get the first derivative of x, which is 3x power of 2 minus 12x plus 18. And if we differentiate once more, we can get the second derivative of f, which is 6x minus 12. The second step is to find the interval of the function x. So what we must do is we take the second derivative of f, we equal it to 0, and then we can get 6x minus 12 equals to 0, and we need to find the value of x, which is 6x equals to 12, and then find the value of x, which 12 is divided by 6, and then we get the x value is 2, which means that the interval is 2. And step 3 is to determine it is concave upward or downward. We need to test the number in the interval. So let's say the interval it is negative infinity to 2, and the test number is negative 2. So we substitute the test number into the second derivative of f of x, and then we get negative 24, which is less than 0. The second test is the interval 2 to infinity, positive infinity, and the test number is 4. And then we substitute the 4 into the second derivative of x, we get 12, which is more than 0. Therefore, if second derivative of x is less than 0, then it will concave downward on the intervals. Meanwhile, if second derivative of x is more than 0, it will concave upward on the intervals. Moving on to question B, which is the question given suppose that the cost function for a manufacturer is given by cost function Cx is equals to 0.000001x cubed minus 0.003x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. Number 1 Roman, find the marginal cost function. And number 2 Roman is describe the behavior of the marginal cost function, whether concave upward or concave downward. And we need to prove our answer. Moving on to the solution for question B1 Roman, we need to find the marginal cost function. To find marginal cost function, we need to find the first derivative of cost function. Given from the question is cost function is equals to 0.000001x to the power of 3 minus 0.03x to the power of 2 plus 5x plus 1000. When the derivative is applied to the cost function, it is 0.000003x to the power of 2 minus 0.006x plus 5. For question 2 Roman, we need to identify whether it concave upwards or downwards. So we need to find the second derivative of the cos function, and we can get 0.000006x minus 0.006, and then we need to let the second derivative cos function equals to 0, and we can get the x value, which is 1000, and it shows that we had found the interval's value, which is negative infinity at 1000 and also 1000 to positive infinity. And the next step is as we have done on the question A, which is we need to test the number on the intervals. By using the first interval, we test it by using the negative 0.003, and we substitute it on the second derivative cos function. We can get the value of negative 24. And then if the interval 1000 and positive infinity, we use the test number, which is 0.006, and we substitute it into the second derivative cos function. We can get 12, which means it is more than 0, and from that we can conclude that if the second derivative cos function is less than 0, then it will concave downward on the intervals, while if the second derivative cos function is more than 0, then it will concave upward on the intervals. Move on to question C. Question C. A company has established that the revenue function in Ringgit Malaysia is 2x to the power of 3 plus 40x squared plus 8x, and the cost function in Ringgit Malaysia is 3x to the power of 3 plus 19x to the power of 2 plus 80x minus 800. Number 1 Roman, we need to find the level of production that will yield a maximum profit for the company. And number 2 Roman, we need to find the price per unit that maximize the profit. So for the solution for number 1 Roman, we need to find the profit function. Profit function formula is revenue function minus by cost function. So we take the revenue function, which is 2x to the power of 3 plus 40x to the power of 2 plus 8x close bracket minus open bracket 3x to the power of 3 plus 19x to the power of 2 plus 8x minus 800 close bracket. We need to important information, we need to put the bracket on both of the equation so that we can notice if there are any changes needed on the symbols, and then the next step is 2x to the power of 3 plus 40x to the power of 2 plus 8x minus 3x power of 3 minus 19x to the power of 2 minus 80x plus 800, and we can get the final value of profit function, final equation for the profit function, which is negative x to the power of 3 plus 21x to the power of 2 minus 72x plus 800. So the next step is we need to find the derivative of the profit function, which we take from the original profit function, and we apply the derivative, and we can get the negative 3x to the power of 2 plus 42x minus 72. And to find the level of productions, we need to let the P prime x is equal to 0, and we can get the value of the 0, which is x equals to 2 and 12. To find the exact unit or that maximize the profit, we need to do the second derivative of the profit function, and we can get negative 6x plus 42. To determine whether it is a maximum or minimum or inflation, we need to substitute the value of x that we have calculated just now, which is 2 and 12, into the second derivative profit function. If the x is 2, then we can get the value is 30, which is more than 0, which is minimum point. And if we substitute the x value, which is 12, we can get the value of negative 30, which is a maximum point. Therefore, the level of production that maximizes the profit for the company is 12. Number 2 Roman, we need to find the price per unit that maximizes the profit. So we need to substitute the value of x, which is 12, the level of production, into the profit function. The profit function is negative x to the power of 3 plus 21x to the power of 2 minus 72x plus 800. So we need to substitute the x value, which is 12, and we can get the final amount, which is 1,232 unit. How do we need to find the price per unit? We need to divide the 1,232, divide it into 12, and we can get the final answer, which is 102.67. Therefore, the price per unit that maximizes the profit is 102 ringgit and 67 cents. That's all from me. Thank you.